In this question, we've been given information about a particle, and we've been told its mass, we've been told that there's a single force acting on it, and we've been told its acceleration in vector form. So we are going to be making use of vector form and probably some of the skills associated with vectors as well. Very first question, here we go. We're asked to find, in degrees, the angle between the acceleration and the vector I. Okay, so let's have a look at the acceleration vector. Acceleration 12, negative 16. What would this look like if we were to draw it? 12 to the right, 16 down. This is the vector. The diagonal line is the vector. And we want to know the angle between that diagonal line and the vector I, the unit vector I. Well, the unit vector I is just one step to the right, just one unit to the right. So this is the angle that we're looking for, and I'm going to call this theta. Okay, so we're going to use trigonometry to find theta. It's going to be inverse tan of the opposite over the adjacent. So inverse tan 16 over 12, and that gives us an answer for theta of 53.33 degrees. Part B says we should find the magnitude of F. Okay, firstly, F is that force, and we're going to use F equals ma to get an expression in vector form for that force. So we'll just substitute the mass of 0.5 and the acceleration vector. That gets us 6, negative 8 for the force in vector form. The magnitude of the force, we basically need to do Pythagoras. That's going to tell us the length of the diagonal in that vector diagram. Okay, so the square root of 6 squared plus 8 squared. I hope you recognize this. This is going to be 100. Square root of 100 is obviously 10. That force is 10 newtons. Okay, so in part C, we're told that the velocity of the particle at time t is v meters per second. That's a bit redundant. We always know that v is the current velocity, or final velocity, as you might hear it called, at any given time. So the question then says, if we know that time equals 0, v equals negative 20, 30. Okay, let's not get confused here. If t equals 0, then we're talking about the initial velocity. So although this is labeled as v, this is the initial velocity. We can use that for our u variable. The question goes on to ask us to find the velocity of the particle when t equals 3. So after 3 seconds, what will be the new velocity? Okay, what will be the current velocity? What will be the final velocity? So let's go ahead and collect our Suvat variables as usual. We just want to make sure that we can get these in vector form this time. So the displacement, we don't actually know right now. The initial velocity, like I said, is the negative 20, 30. Final velocity is what we're looking for. The acceleration we have earlier in the question, and the time is 3 seconds. So making use of these, it's going to be v equals u plus at. Substituting in, and here we just want to find the resultant of this right hand side. So negative 20 plus 3 times 12, and 30 plus 3 times negative 16. And that gives us a velocity vector of 16, negative 18. If we'd been asked for speed, we'll need to find the magnitude of this and apply some Pythagoras. Or if we'd just been asked for the magnitude of the velocity vector, we'll once again need to make use of Pythagoras. Since we haven't been asked, we're okay to leave it in this form.